This is the third in a series of videos on the sampling distribution of sample means. And in this one we look at an example problem. So the example problem is this, let's say you have a herd of cows, a herd of 1,200 cows, and the average weight is 650 pounds. And the standard deviation is 72 pounds. So if you think about this, here the population is the 1,200 cows. So mu is the true value of the population, or the average value of the population. That's 650. And sigma, that is the true value of weight of your cows, is going to be 72 pounds. And now what we're going to do is we're going to take a simple random sample. So actually what we're going to do is we're going to sell 30 cows. But the problem is if we sell 30 cows, we're going to get the person buying them is going to get angry if the cows don't weigh enough, right? So what we would like to know is, if we take a random sample of 30 cows, what's the probability that the average weight is at least 624 pounds? So in terms of, we're going to calculate X bar, and we want to know what's the probability that X bar is greater than or equal to 624. And let's do some notation here. A real compact notation would be that X is a random variable, and it's distributed 650 and 72. Now let's go back to our original problem. If you notice, there's no assumption here that the weight of the cows is normally distributed, right? You could, in fact, have a very skewed distribution. You could have a distribution like this, where you have a few cows which weigh quite a bit, and most cows weigh less, and your mean could be here, right? That's possible. You could have a skewed distribution. It doesn't say that you will, but you could. And the key is the central limit theorem allows you to assume that even though X is not normally distributed, X bar will be, as long as N is big enough. So the central limit theorem says that X, if X, even if, let's say this, even if X is not normally distributed, X bar will be normal if N is large enough. And most people say large enough is about 28 or 30. So let's go ahead and get started. So in this case, we can make, if we know that X is distributed 650, 72. That is, mu is 650, sigma is 72. And there's three things that we know. Number one, mu X bar will equal to 650. And the second is that sigma X bar will equal to 72 divided by the square root of your sample size. And your sample size is 30 here. So what we need is a calculator. So remember, this is the formula. The formula is sigma X bar is equal to sigma over the square root of N. So let's do that real quick. 72 divided by 30 square root. And you get about 13.15. Let's see, if you do that again, 30 square root, if you want to do that, 30 square root is around 5.48, 72 divided by that. Good to always check your numbers. You get about that, 13.14, 13.15. So this is the picture that we're going to draw. We're going to find the probability that X bar is greater than or equal to 624. So we're going to have a picture that looks like this. The mean here is 650. 624 is about right here, say. And we're going to find the probability of this region right here, the shaded area. So what we're going to do is we're going to convert x bar to a z-score. And the formula we're going to use is z is equal to x bar minus mu over sigma. But be careful here. This sigma that we should use here should be sigma x bar. And this mu here we should use be mu x bar. So this is the same one you learned before, but now we're doing it for the sampling distribution x bar. So that z is equal to 624 minus 650 divided by 13.15. Right, that's how we got the 13.15 is we calculated it using this formula right here. And let's do this, 624 minus 650. If you do that on your calculator, that's going to be a minus 26 over 13.15. And if you go 26 divided by 13.15, you get 1.98, a minus 1.98. And if we draw that picture, if you draw the distribution of z, the mean will be 0, and you're going to find, if this is minus 1.98, you're going to find the probability that you're to the right of that value. And this is your z-score, or z-value. Now, how do you do that? Well, that you're going to need a table. You're going to need some type of z-table, though many graphing calculators can do it as well. You're going to look at the standard normal table. Now, the thing about a standard normal table is a standard normal table will always give you the value to the left. In this case, you want the value to the right. So let's read that off. Minus 1.98. You're going to go minus 1.9. And you're going to go over to 8, so you get 0.239. So this value is 0.0239. So your overall value will be 1 minus that. And if you get 1 minus that, you get 0.9762, if I did it right on the calculator. So in other words, you're pretty safe. You have about a 97% chance, actually a little bit better, of having cows, a sample of 30 cows where the average weight is greater than 624.